The Port of Shanghai, engineering the future of global trade. Introduction. The challenge of connectivity in the intricate landscape of global trade. Each thread signifies not only goods but the sophisticated systems that enable their transit. Among these threads, the Port of Shanghai stands out as an engineering marvel that has transformed maritime commerce since its developments began in the late 20th century. As a leading global port, its creation and expansion were not merely reactions to increasing trade volumes, but monumental projects addressing engineering challenges, environmental constraints, and economic needs. Context. A historical perspective. The Port of Shanghai's history stretches back centuries, rooted in its advantageous geographical position at the confluence of the Yangtze River and the East China Sea. Its prominence as a trade focal point dates to the 19th century, but it was only during the late 1970s and 80s that Shanghai's potential as an international trade hub became evident. This was a time of transformative economic reforms led by Deng Xiaoping, aimed at modernizing China's previously isolated economy. Investment influx and technology sparked ambitious modernization plans for Shanghai's outdated port facilities. The challenge was clear. How could the Port of Shanghai be engineered to meet existing trade volumes while anticipating future growth? The engineering challenge. The vision was to create a port that could rival the world's top maritime logistics centers through innovative technologies and efficient designs. Initial surveys indicated that existing infrastructure would be inadequate to meet growing demand. Engineers faced substantial challenges, including the need for deep water for larger ships, the capacity to handle millions of TEUs of container cargo yearly, and the environmental concerns of constructing near a major urban area. The project exemplified the engineering principle of balancing functionality, cost, and ecological impact. Proposed solutions. The port's evolution to tackle these challenges. A master plan emerged in the early 1990s, leading to the creation of the Yangshan port. This was connected to the mainland via an impressive bridge and road and rail links, marking a multi-phase construction project featuring several engineering milestones. One Yangshan Deepwater Port. Inaugurated in 2005, the Yangshan Deepwater Port showcased engineering prowess. Located about 30 kilometers offshore to accommodate mega-container ships, engineers navigated natural challenges, including typhoons and complex seabed conditions, through precise geological surveys to ensure stability against seismic activity. Over 100 million cubic meters of dredged material were used to create deepwater channels up to 40 feet. This depth allowed the world's largest container vessels to dock safely, and the port's modular design permitted phased expansions to respond to trade growth. 2 Donghai Bridge. The Yuanshan Bridge, or Donghai Bridge, opened alongside Yangshan Port. Spanning roughly 32 kilometers, it was engineered for efficient transportation of goods to and from the port. Designed as a cable-stayed structure, it was optimized for regional wind and seismic activity, reducing material costs while ensuring structural robustness. Its construction required meticulous coordination with maritime traffic, adhering to safety protocols. 3 terminal operations and automation innovations in terminal operations were vital to the Port of Shanghai's evolution. Automated quay cranes and autonomous vehicles streamlined container handling, significantly lowering turnaround times. Advanced logistics technologies allowed for real-time tracking and optimized traffic flow within the port. Automation enhanced efficiency, reduced labor costs, and mitigated human error, enabling the Port of Shanghai to retain its title as the world's busiest container port for several consecutive years. Difficulties and breakthroughs throughout construction and operation. Challenges tested the resilience of engineers and planners. Environmental concerns. Addressing environmental issues was crucial, as dredging and land reclamation raised worries about habitat destruction. Engineers implemented robust management strategies, including creating artificial wetlands to compensate for lost marine habitats, diversifying the local ecosystem. Logistical coordination. The project's scale demanded meticulous logistical coordination. Synchronized movement of equipment and labor across land and water required innovative planning and project management methods that allowed for quick adaptations to constraints. Adapting to change as trade dynamics shifted due to economic fluctuations, engineers continually refined operations. Modular designs provided flexibility, enabling the port to swiftly adapt to future demands. Real-world impact and significance. The completion of the Port of Shanghai was more than an engineering success. It fueled China's broader economic ambitions. The port improved the efficiency of goods transfer, lowering shipping costs and enhancing trade speed, bolstering China's market competitiveness while creating millions of jobs in Shanghai and beyond. Its innovations set a benchmark for other global ports, inspiring modernization projects worldwide and affecting global shipping infrastructure positively. The closing reflection, the Port of Shanghai's evolution, reveals that its engineering impact transcends architectural achievement. It epitomizes a nuanced understanding of global economics and a commitment to innovative solutions for environmental and logistical challenges. As a testament to engineering's power, the Port of Shanghai embodies the future of global trade, exemplifying how adaptability and resilience can confront challenges, paving the way for the next chapter in commerce and connectivity.